Becoming an AI engineer in 2026 doesn't take years. It took me 3 to 4 months to learn AI and land my first job building prediction models for the stock market. Since then, I've built AI for Apple Vision Pro, self-driving cars, and I have multiple AI patents. Companies like Apple, Google, Meta, and Netflix headhunt me for AI positions, and I don't even apply. I'm going to show you the exact roadmap to become an AI engineer as fast as possible. 4 phases: foundation, working with models, building real systems, and getting hired. Let's get into it. So what exactly is AI engineering? Well, AI engineering is not data science. It's not heavy math focus. It's not training models from scratch. So you not necessarily have to implement and use on a daily basis calculus, statistics, learning what forward propagation is, back propagation, creating things like that, activation functions. You don't have to train it from scratch. You don't have to learn a programming language and actually build out all the models and the neural networks from scratch, right? The main thing is, after all these years, these models exist. So there's pre-trained models. What they want is real-world implementation. That is what the role is. They want to be able to take messy data, be able to clean it, such as you have the dates from a POS, like a point of sales system that is basically like if you're dealing with retail, and you might have a lot of data in there, and you might have dates from different systems, from the internet, from the POS, and the dates are not standardized. So you might have day, month, year, and some of them might be month, day, year. Some years might have 2 digits, some might have 4. Now the thing is, you can't just take the raw data and put it into a model. It will not give you the proper results that you need. So you want to show, how do you deal with real data? How do you curate it, meaning to collect them all? How do you clean it and standardize it? How you deal with missing data, how you format them. And then knowing how to use Python scripts will be very helpful to actually clean these things out, even if your models aren't able to actually do it for you. So knowing scripting will actually augment you as opposed to just relying on the tools by itself. The main thing you want to do as an AI engineer, and not necessarily a researcher, is to bridge research to production, actual production itself. That's what doing that bridge is. You could read a paper and find out like a certain technique or the state of the art, but you want to translate that into working code or a working system. That's what AI engineering actually is: taking a model that exists, something that abstract from a paper, but applying it to the real world. And you want to solve business problems first. You want to see what real users are actually facing, and making decisions that actually affect the actual financial impact of the company, making real money decisions here. Companies and already have models that exist, or basically there's models that exist that companies could use rather, right? And you want to be able to connect those models to the actual company data to make it relevant to their use case. And you want to build usable systems for them, not just toy examples or tutorials. And you want to make sure that it's fast, that it actually gives feedback, that it within a reasonable amount of time given the context, it's reliable, that it consistently gives feedback, and it's cost effective. Basically, the ROI, or the return on investment, the amount of money of the operation cost to learn and to set it up, is a lot less than the profit they make or the gains they get in terms of time savings or money saved or money gained off of it. Let's get into the blueprint. Phase 1, the foundation. When you're learning, when you're actually using AI engineering in the end, models pre-exist and you can put them together. But when you're learning to understand how it works, you should understand how ML models or the general process is done, even though you might not do it in the end. For example, in the real world, you might be using a calculator, but in school, you learn how to do long division and multiplication tables by hand, even though you'll never actually use it, but it helps you understand what actually happens at the back end. So for this case, if you're going to be serious about this, learning Python is non-negotiable. Every AI tool uses it. Not necessarily that it's the best, it's the standard. And a lot of the frameworks are built on it. Like right now, PyTorch is the de facto or the standard framework to use. So when you see new papers, most likely they're already done in PyTorch and there's implementations already out there. You just learn it. You can learn other languages. Not impossible. You could do it in other languages. In fact, 10 years ago, we had to build it, and you could do these frameworks didn't exist. So you built your own, and you can do it in other languages. But the thing is, if it's not consistent, you're going kind of like going uphill, because Everything else is already using one language and a certain style. Learn that style so you could work in that ecosystem. The other thing is learn just in time. Basically, learn what you need when you need it. That's what it means, just in time. Don't go down the rabbit hole and you learn every little thing that might not be relevant to your use case or your problem. You want to make sure you're solving the problem first. So you should be asking, if I learn this, is this actually coming closer to solving the problem that I have? And if not, you want to evaluate. Most likely you don't need it, right? You don't need full courses needed, right? You just need to learn what you need out of that and move forward. An example of this, if you go to a new country and they speak a foreign language, you can just be immersed in there for about 2 weeks and you can pick up enough of the language to get by. Now, are you a master of it? No. Did you go to a course beforehand? Is it required? Do you have to sit down and read every single word in the dictionary? No. And then you should do the same thing. You learn just in time. You learn what you need for the context you need to get by. The other thing is, at the beginning in the foundations here, like I mentioned, Python is non-negotiable. You should learn the core Python modules that you should focus on. And the main things are the data structures, because if you just go and say learn Python, you might get 100 days of Python. And not all of that might be relevant for what you're trying to do if you're trying to be an AI engineer. The main thing you want to focus on, make sure you understand data structures in Python, main things like loops and functions, how to work with JSON or CSV or comma separated values, which is basically you go into the Excel sheet, for example, or Google Sheets, and then export them out as text with commas separating the values for the tables. And APIs, which is application programming interfaces, how programs are able to interface with that. That's very common, especially if you're dealing with web technology, right? And here are the data stack essentials, or the data science stack essentials, which is modules that are built on top of Python. Again, this is specific if you're trying to learn AI engineering. If you're just going in, and why I'm saying it's very specific for that is if you're just going to say, okay, I'm going to learn Python, 100 days of coding, just general Python, you might never learn NumPy. Maybe you do, but like you might not know it. And the thing is, in this space, NumPy, like PyTorch, all these things are all standard in the current papers and space. So NumPy is like the math modules to do a lot of numerical calculation. PyTorch is built on top of that. Pandas is able to take like CSVs or Excel files directly and import that, and then you start processing the data. And then Matplotlib and even Seaborn, which is another module in Python, helps visualize that data so you can explain that and visualize data to non-technical people or stakeholders of companies so they could give them an informed decision. Other thing I would say is learn Git. This gives you basically source control. Basically, when you write code, when you're learning Python, one of the problems when people start is that they write code that works and then you try to add a feature or function and then it stops working and they don't know how to go back or merge the code to the previous. Git and learning how to source control your code to keep every version of it, so you know how to add features, how to work in a team, how everyone works on the same code base, and how to go back and revert back to your old versions of it. You learn how to track the changes, and it avoids breaking code, because even if you're in a version that doesn't work, you could always roll back. And this is how professionals work, and you should learn how it works, even if you might not be doing it right away in your actual professional career. Once you start coding and start working with even if you don't code yourself, but even working with coders, because most likely you will be interacting with these type of people at some level, you understand how they do this in professional setting. The other thing about this is that it might sound, okay, if I'm going to have to learn the foundational stuff and Python, even though I'm not necessarily going to be a coder, just to learn this stuff, to understand it, do you have to get an expensive computer and buy like the latest GPU or a gaming computer? You don't need any expensive setup for this, because if you have a Gmail account, you probably know that if you go into Gmail, you might have a G Drive. You will have a G Drive if you have Gmail, and you'll see that you could create like Google Docs, which is like Google's free version of Microsoft Word and Google Sheets. Well, there's a lot of other things you could create, and they're usually on the three dots. You'll see there's one called Google Colab, or probably the full name Google Collaboratory, and that allows you to code in Python for free with GPU, which makes it exponentially faster, for free directly onto the Google platform in the cloud. And this is great because You don't need a powerful computer. You just need a computer and the internet, whether it's a Mac or it's a Windows, Linux, whatnot. Like if you're using Ubuntu, you can work most likely on mobile device as well. So you can start this today. Just go in, get a Google account, start working with Google Colab, and start looking up the Python foundations and focus on like data structures, loops, and these things like JSON, CSV, and APIs. Phase 2 of this blueprint is working with models. So you want to start touching AI models. So the first part in phase 1, you're learning like the Python basics foundation to understand how it works. Now you're actually touching AI models. You're going to learn prompt engineering skills. You want to be able to give clear instructions, structured context, and examples of output of what success is supposed to look like. Basically, imagine that if you were to hire an assistant to do work for you, what are the instructions you would give them, in what context like you want them to work so they understand, and then you show them by modeling them or show them examples of what success look like or the output, how it's supposed to be. And that same way you give those instructions is how you could approach prompt engineering and build that skill set. The other thing is you want to be able to configure these models for business, basically their business cases, right? And the other thing is about that is that when you're explaining to other people, try to aim to explain at a 4th grade explanation level, and is not basically condescending. It's basically to reduce the jargon, because you will be well versed in this space, but you're hired because you're well versed in the space. Everyone else is not. They are not well versed in the space, so you have to be able to explain it to them in a way that they can understand and make recommendations to them so they can make a decision to stakeholders and whatnot, right? The other thing as well is using API-based model usage, right? So what that means is that, now, like I mentioned today, these days AI models already exist, so you could just use them. You don't have to train them like ML, like using machine learning to build neural networks like it was 10 years ago. You still can, but it's not, unless you're going to be researchers, that's not the best approach to it or most cost-effective ways. If something already exists, use it. The only thing about that is you have to measure. It's going to cost money if you use it commercially, right? So most likely if you're going to use APIs, basically the way to communicate with those models, and if you're not using a certain framework to do it without code, you're going to use API calls, and you have to understand how much it costs to do that. And if you're going to build like chatbots or assistants and all that, you want to know how much a token, because usually you buy tokens and it costs a certain amount, and you could use a certain level per month or daily usage depending on how they're priced. You have to be aware of how much that costs, because when you build your solution and you present it to the stakeholders who's going to make the decision on it, you're going to say it's going to cost this amount, and you forecast how much usage is going to be, versus if we didn't have this, how much cost it would have taken or how much we would have lost, versus all that. So they need to understand the usage of that, so because it's not free, right? The other option, if you don't want to pay at all, and I have use these as other options, you can use open source models options, and this is where learning how models work and knowing the foundation helps, because now the thing is, the models are not paid and they're not in the cloud. You could use local deployment, meaning you could put it directly on your computer, which helps as well, because you could, if you were very concerned, or companies are concerned about the environmental impact, well, if you could do it on your computer, whatever it costs to operate the actual app is how much it's going to cost as well for that, which is normal CPU or GPU usage of that. And now the thing is, what's good about the data stays internal, which is always a problem when you start using external commercial solutions. Companies are like, well, we don't want to give our data out. So that's another solution of it. And overall, it could be lower long-term costs because you might not be paying per token. But the downside of this is that you might be using models. It might take a little more setup to build it, and might not be as user-friendly. Again, if you know how models work in general, and you know the foundations of Python and coding and all that, you could get around the concepts for that. The other thing is that open source models usually are not trained with the best data out there that a commercial one is. So even if you have the model, it might not give the best output. but a lot of options is that you could train it yourself. They teach you how to, or tell you how to train it. And goes back to taking the data from the company and actually manipulating it and giving it a local model. You can make something specific for the company that is optimized for the company, but you have to know how to actually manipulate and do that. And this is why learning these things will make you much superior and stand out from the crowd. Now, for the open source, there are options such as Hugging Face, which is a platform that, think of it as like GitHub. GitHub is like a repository, a platform, kind of like a social media platform. You could think of it in a way, but for coding. And it's kind of like known. You might have heard of it, even if you don't use it. It's kind of like known. Hugging Face is a version, kind of like that concept, but for models. So you could explore models that people upload there. You could use like transformer libraries and deploy locally, and then use your data on that. Again, these are open source. A lot of them are. Some of them might not be. You have to again check the licensing of it and just make sure the data, how the license of how you could use it with your data, and if you use it in your own data, you have to share it. Again, when you're working with any of these things with a company, you usually run it by their legal team and also the executive team to make sure everything you're doing falls in line with the company. But these are the main things you want to be focused on, and that's why phase 2, you want to be aware of these. Now, phase 3 is actually building real systems. Now, this is what's going to separate you from everyone else who's just doing tutorials. You can start off with tutorials to understand how it works, but you want to switch to real systems afterwards. Learning things like LangChain for orchestration. LangChain is to deal with LLMs, or large language models, with Python and JavaScript. You want to be able to chain these together, use the tools, how you work in memory. What is a multi-step workflow for these? The other thing about building a real system, especially this day and age, if you recall, not too long ago, using LLMs, if you ask it a question, it seemed like it's a good answer, but then it starts hallucinating or making up answers. Now there's other techniques using like RAG and also like agentic or agents. So RAG, basically you could take additional data, so it actually could use that as a source. And this is especially if you know how to do that, you could build it specifically to the company data and use things like embeddings and vector database and internal documents to help give more meaningful results from when using these models, but specific to the data of the company. And then agentic or agent workflow, what this does is, like, for example, LLMs are notorious for learning how to work with large language models, but you could give it a word problem, like a math problem. Like if Tommy walked down and took 3 apples and he dropped 2, how many do you have left? It sounds simple, right? But something like that, a large language model might get confused because it wasn't necessarily trained on extracting the concept of a mathematical problem like that and then doing simple math on that, right? It was meant for languages, not necessarily math. So a way around that, instead of like making it even larger to try to be an expert in math as well, you could actually just give it a program, like another app that it could call, like in a calculator or like a computer programming language like Python. It could off the calculations to that's already optimized to do that type of work, get the results and bring it back. So that's like an agentic workflow. And you could do it with many things, like how it could read how to analyze pictures, get that information, bring it back, or OCR, which is optical character recognition. So you could take a picture of words and then it could recognize what are the actual characters or the letters or words in there, and then you could give that to the agent. So that's a powerful workflow, understanding how that works and how it connects to AI, APIs and databases, and then using that workflow to automate real work. So that's what basically using agentic RAG systems to search and work with multiple agents and chain them all together. And the other thing is, once you have your systems built, and another incorporation or important part is DevOps, or development operations. So this is kind of like what this is talking about for large language models. So once you create one, how do you monitor performance once it's actually working? How do you control the cost, which we mentioned before, of tokens if you're using external things, or if you're dealing with internal local computers to calculate these things if you're not using the cloud, and then how you optimize the results and then deploy it, take a new train one and replace it. These are things you want to look into because this is what you're going to have to do when you work with real companies. Now for phase 4 from the blueprint, getting hired. Now the thing is, portfolio proves your real skills. So if you have GitHub projects where it actually show the end result, so pretty much if you have the code, you have the explanation what it is, and if you have like videos and pictures showing what it actually does so people understand, and also showing the data that you work with, especially if you're working with real world data and not like curated data that's already perfect, that it just plugs in and everything works. Showing that we got this from the real world, and then we made tools to help clean it and organize it so we could actually put in the model to actually train. And the thing, having one strong end-to-end project with documents with questions and answers and citations, and you talk to the data agents and you show like email automation flows. This is just an example of like real world scenarios that it would be analogous to what actually happens in the company. That would be way more powerful than showing another like to-do list example from a tutorial, right? You really want to show business value and how your projects link to them and how it would save time and reduce errors and what's the money impact for it compared to their solution before. Basically not having your solution, this is what you get right now. And once you implement the solution, these are the time savings, the error reduce, the money impact, the business impact for it, right? You always want to put everything through that lens. And once you've done all this, you want to make it public or visible what you've done so people are aware of it. So you want to market your results publicly. And you want to do it on some of the prime platforms or LinkedIn and Twitter. LinkedIn because it's a professional platform, and Twitter is one of those where it's quick information that people could look while they're doing something really quickly and check it and not necessarily doom scrolling, because a lot of professionals, companies don't necessarily have something, let's say like IG or TikTok, for example, mainly because it might not be aligned with their business goals, but something like Twitter or LinkedIn are more in line with it and it gives more relevant information in this space at least. And the thing is, you want to show the metrics over your learning post, right? So it's not just you post something, you want to give it context and you want to show the metrics of why it matters or what in this space, in this context as well, like what is the time saving, what's the error reduce, the money impact. You always want to put it through that lens and show measurable results by some type of metric to show like this is what it was before, now we can do this faster, better, more cost effective, and it makes more money. There's a wider margin with this, a bigger margin with that, for example. And the other thing as well is when you're trying to get hired, biggest thing, apply before you are ready. One thing I would say is that, let me just move this so you can see it a little better. One thing I learned when I was in university is the ones who graduated and got a job right away, they actually started applying a year before, as opposed to most people, they graduated, everyone give each other high fives, they party and whatnot, and then afterwards they start applying for jobs and expecting like the next week they'll start, and they got a rude awakening. It took a long time before they get a response and they start getting anxiety and whatnot. What I suggest, the process just in general, the pipeline to get hired, it just takes time. So even 2 months in, even if you're not ready finishing all the phases, start applying, because most likely no one's going to respond to you by the next day, right? But by time you start getting ready and feeling more comfortable, you start getting more results. So you want to apply early and be consistent with it, right? The other thing is you want to leverage your actual domain. So if you're already an expert in one specific domain, learning AI on top of it, that's going to give you an advantage, because the difference is a lot of people right now are basically saying, I'm an AI, I know AI, right? Or might say I'm an AI engineer, and then they list a whole bunch of tools and frameworks they know and all certificates they have done. They don't have any real project. So now if they apply to a certain domain and they don't even know the domain and they haven't any real project, it doesn't just because you know AI doesn't necessarily mean you're going to stick out, because everyone's saying that. And now if you are you know a specific domain, you know their pain points, you know what the solution's supposed to be, because you have that industry knowledge, right? Especially in non-tech companies that are not, everybody's trying to use AI, but especially non-tech companies, they might not know how to implement it. And I could give you an example. I know companies who are like in the food industry, and nobody was looking at that at the time. And they started making AI solutions. They had no competition. And this person worked in this industry for 20 years. So they knew all the main things and what could be optimized. And there was literally no contest. Like, he came with a solution. He knew what the problems were, what everyone was. He talked to their pain points, and he presented the actual solution with his AI apps and whatnot, and people jumped on it. So remember, knowing the domain, that is your superpower. It's your advantage here. I want to share my honest truth about this. The roadmap only works if you actually do it, if you actually get it done. And the thing is, the hard part, the real challenge is actually consistency. So the reason why I say that is that you might be motivated. I'm going to do this. I'm going to go out. And people ask me if they've done this in real life. I sat down, people I've worked with, I sat down and worked out for hours and wrote emails and tell them step by step what they need to do. The thing is, it's not sexy. It's really boring at the very beginning. You're not going to get any rewards or any responses at the beginning, especially if you're going to apply for jobs. That's why I mentioned it early, while you're still working on things, because you're not going to feel it as much. Like, wake up in the morning, apply for 5 jobs every single day, like block out an hour in a calendar and do it every single day. You're not going to see results, but after a couple of weeks, a couple of months, you might get 1 or 2 responses, and then it's going to start avalanching, typically, at least, right? Especially if you're doing the right things and you're showing the right stuff doing the right projects, showing it on your resume and your portfolio. The thing is, it's no intermediate reward, and that's the hard part, because especially if you're doing a job now, you go into work, you do what you need to do, what you're asked to do, and you get a paycheck every week or 2 weeks, whatever the cadence is. It's pretty deterministic. When you're building yourself to something new, there's no immediate rewards, and that's what discourages people. So you're motivated at the beginning, and then the motivation dies. You need to stay disciplined just so you can stay consistent, right? And the other thing is, comfort kills urgency. Especially now, if you're just, let's say, doom scrolling, you came across this video and you go, oh, that's cool, that's nice, I want to know what this is. I should look into it sometime. A lot of people might be already comfortable where they are. They have a job, it works. It's already stressful, or you already have a certain amount of time, and your free time, you might want to do something that's more recreational. So I don't want to sit down and start doing work for a while where there's no immediate results or there's no response. So, I'm going to skip it today, or I'm going to skip the next day. And the thing is, there's no urgency. But when you have a deadline and you're like, okay, listen, if you don't get this done and deliver what you need by next week, then your current position and the current job might be gone because it's being replaced by AI. Or I know if I can augment my skills, if I knew AI, I can get a better position. I just have to sit down and build it even though I'm comfortable right now. I just know in the future that it could be in jeopardy. That's the thing. Like, if you're not already in an urgent situation that it could skip out and you don't see any immediate detrimental feedback, most people is just gonna skip and just stay in their safe lane. And that's a problem until it's too late. When urgency comes, by then it's too late. Just kind of like I mentioned earlier, where the people I've seen successful when they graduated, already had a job, to them it was they created urgency a year ago, because they realized in a year I don't want to be in a spot where I'm scrambling and everyone's trying to find the job and I have nothing to hang on to, right? And I've seen it happen with people where they're completely fine, and then out of nowhere they just got layoffs. Not because they're not skilled or whatnot, just because of the current temperature of that industry. There's industry shifts, there's things that happen that they have to downsize for whatever reason, and I know people who had very secure jobs for 2 decades, thought they were irreplaceable, then all of a sudden they have to go look out for work, but there's so many other people looking for it. How do you differentiate yourself from it? That's why creating urgency now, even if it's basically manufactured, is very important, because when it does matter, when urgency does come, you already be prepared, or you already moved on. And this is why it's very important to have accountability, finding other serious people in your space that are trying to do this to help maintain that urgency, that generated urgency manufactured urgency, because you might be comfortable right now. And this is super important for that to keep forward, because right now you might be motivated. When you're not motivated and you don't want to do it, that's where the accountability and the serious people can help you out, right? To stay disciplined and keep forward. And one success that changes everything, what I mean by that is, most likely when you start off, everybody fails. You're not going to hit a home run on your first swing. You're going to fail 1,000 times. And if, again, that compounded with the fact that you're getting no response for all the work you're dealing with, no immediate responses for all the job applications you're putting out there, and there's no immediate reward, and you're giving up your comfort because you don't really have any, you're just yet the moment. That is really hard to go through mentally, and that's where you have to be strong, because you're going to fail a lot of times on top of that, right? But the thing is, getting that one success automatically nullifies all that, and that's what people remember. They're not going to remember all the failures beforehand, right? And even for me, getting my first job was proof of that after working for like 3-4 months learning AI and actually getting my first job predicting the stock market, predicting like where the market would go in the stock market, so we could actually put it for a portfolio that is meant to beat the S&P 500, showed that, okay, all that work actually paid off. So for me, my main thing I would say is that if you're really serious, don't put this off. Don't stay comfortable. You want to actually have urgency. If you have to create it yourself, get accountability. Find other serious people so you guys can stay disciplined when you're not motivated. But the most important, start right now.